Okay, worksheet 8, problem number 3. We're going to use y equals the sum as n goes from 0 to infinity c sub n x to the n power. Substitute that in along with its derivatives, and then combine the sums. Here I have y double prime plus x times y prime plus y. So I'm going to start with my definition for y. Y is the sum as n goes from 0 to infinity, c sub n x to the n. And then my first derivative, bring down the exponent, bring down the n, and decrease the exponent by 1. Notice that it doesn't matter if I leave this lower limit at 0 or change it to 1, because when n is 0, I'm just going to have 0 for my term. C sub 0 times 0 x to the negative 1. The term is going to essentially be 0. And then my second derivative, again, bring down the exponent and decrease the exponent by 1. And again, I could increase that lower limit because the n equals 1 term will essentially cancel out. This n minus 1 will be 0, and again you end up with another 0 term. So this is what I'm going to substitute into the expression for my y double prime plus x times y prime plus y. Now, in order to combine these into a single sum, there are a couple of steps that I need to take. The first one is I need to look to see if there's anything outside of the sum that can be brought inside. Specifically, anything that contains x. So on the second term, this x, when I bring it inside, is going to increase this exponent by 1. That's what I get here, x to the n. The first and the third sum did not have anything outside of it. Okay, next I want to look at the exponents, and I want all the exponents to be the same. In order to get the exponents to be the same, I'm going to use a change of variable, and for each individual sum, I'm going to let k, or whatever variable you might happen to choose, equal to whatever that exponent is. So in this first term, I'm going to let k equal n minus 2, and that way n is k plus 2. On the second term, I'm going to let k equal n, and on the third term, k is equal to n. Again, that k is equal to whatever the exponent happens to be. So making those substitutions, when n is 2, k is going to be 2 take away 2 is 0. Then I get c, n is k plus 2, n is k plus 2, n minus 1 is k plus 2 minus 1, or k plus 1, and then x to the k plus, and then for the second and third sum, I'm just replacing the n with k. K equals 1 to infinity, c sub k times x to the k, plus the sum k equals 0 to infinity, c sub k x to the k. Okay, so all my exponents are the same, x to the k, x to the k, x to the k. Next, I want to look at these lower limits of the sum and make sure that they are equal. So here I have k equals 0, k equals 1, k equals 0. I want to expand to the higher value of k. So on this first sum, I'm going to take out that k equals 0 term, and that way inside of my sum I'll be left with the sum from 1 to infinity. It'll match the second term. Same thing with the third term. take out the k equals 0 term, and you'll be left with k equals 1 to infinity. So on the first term, when I take out the k equals 0 term, this will become c sub 0 plus 2 is c sub 2. 0 plus 2 is 2. 0 plus 1 is 1. X to the 0. So my k equals 0 term. And then I can increase this lower limit to a 1. Plus the sum as k goes from 1 to infinity of c sub k plus 2 times k plus 2 times k plus 1 times x to the k. The second term was fine, and so it's just copied. And on the third term, expand that k equals 0 to bring it out. And you get c sub 0 x to the 0, and then plus, and then increase that lower limit by 1. K equals 1 to infinity, c sub k x to the k. So here what I'm going to do is I'm going to take these terms that are outside of the sum and bring them together. So this first term is 2c2, and this term here is just c0. Those are combined, and then the three sums are just copied. Notice that they all have the same exponent, they all have the same lower limit, so we can combine them into a single sum. When I combine them, I'm going to factor out the x to the k. Here's my x to the k factored out, and my k equals 1 to infinity. And then I've got my coefficients here, c sub k plus 2 times k plus 2 times k plus 1 plus c sub k times k plus c sub k. Okay, so this is technically is a good answer, and it's answered the question that was asked. It's combined all of the sums into a single sum. But notice that you have a c sub k in common, which you could factor out, so that this these last two terms inside the brackets become c sub k times k plus 1. And so again, this is a good answer. But notice here that you have a k plus 1 in common, and so you could factor the k plus 1 out, and that will give you this final answer. So again, any one of these last three answers technically are correct.